Hey y'all, it's everybody's favorite geometry teacher here to finally talk to you about something other than triangles. And we're going to talk about quadrilaterals, which hopefully is a word you're familiar with. It's a polygon that has, you guessed it, four sides. That's what the quad means. Specifically, we're going to talk about a special type of quadrilateral that we like to call a parallelogram. So this unit's going to be pretty heavy here with properties. What I recommend for you to do maybe is to make some flashcards, use some 3x5 cards. You could cut some paper up into smaller pieces, use some flashcards or some way to get these properties down so that you can study them. So the first thing we're going to talk about is in order for a quadrilateral to be a parallelogram, then we need to know something about its sides. So there are two things we know about the sides. Let me just go back up. Remember, pause if I scroll down and you need to see this still. So two things we know about a parallelogram sides. The first one kind of makes sense. It's a parallelogram. The opposite sides are going to be parallel, so the sides across from each other. So here I have AB and CD are parallel. And I also have BC parallel to AD. Okay, and hopefully you all noticed it's a snow day. I'm a little off my game. I just showed you that those sides are congruent. So I actually showed you on the picture, number 2, opposite sides being congruent. Let me go back and fix this and I'll show you opposite sides being parallel. Remember these arrows mean AB is parallel to CD, and we'll make a double arrow for BC being parallel to AD. So I'm already ahead of myself here. The opposite sides are also congruent to each other. So AB is congruent to CD, BC is congruent to AD. Okay, and this is kind of something you guys might say is common sense. If you look at the picture, it looks like the opposite sides are parallel, and it looks like the opposite sides are congruent. And they are. We also need to know something about the angles. This little intro is the same as the previous slide. So we know two things about the angles of a parallelogram as well. The opposite angles are congruent. So here I have A and C are congruent. And again, if you look at the picture, maybe a little common sense, they look the same size, it's because they are. B and D are also congruent. So they are the angles that are across from each other. We've been doing opposite and across in our triangles. Same idea here in our parallelograms. Now the consecutive angles are supplementary. So if I start at one angle, let's start at A. If I go around the parallelogram either way, the next angle I get to is going to be consecutive to A. So A and B are consecutive angles. They are supplementary. If I go the other way, A and D, they're also consecutive angles. They're supplementary. So we end up with a bunch of pairs here of supplementary angles. B and C are supplementary. C and D are supplementary. And again, we've already said A and D are supplementary. So if you know one angle, we can do a lot of things to find the other angles. We know that the opposite angles are congruent. We know the consecutive angles are supplementary. So we really only need to know one angle in a parallelogram in order to find the other three. And same intro here. We're going to talk about the diagonals. Let's first talk quickly about what a diagonal is. It is a segment that is diagonal. It connects the opposite vertices. So we said in the previous slide that A and C were opposite angles. Segment AC connects those two opposite angles, and that is a diagonal. this guy right here. Every quadrilateral has two diagonals, so the same is true for parallelograms. So I have diagonal BD as well. And the thing we know about parallelograms is that the diagonals bisect each other. That means they cut each other in half. So A, and we'll call this point E, AE is congruent to EC, and BE is congruent to ED. So we have two pairs of congruent smaller segments because the diagonals have bisected each other. So that means that E is the midpoint of both of those diagonals. So when we have a parallelogram, if we know a quadrilateral is a parallelogram, we can use that information to do a little algebra, to find an angle, to find a side, to find the length of a diagonal. So let's look at a couple examples here. This first example here on the left, I know this is a parallelogram. I was told that up top. And these two sides are opposite of each other. The big thing I know about those is that they're congruent. So I can find x, setting up this equation, and solving for x. So I'll subtract 16 from both sides. And I can multiply both sides by -1 to get that x is 9. Over here I have some angles labeled. They are opposite from each other. Go back and look at your properties for angles. The opposite angles are congruent, so I can simply set up another equation, x plus 4 equals 65. And this should be a nice, pretty easy equation to solve. Subtract 4 from both sides, the x is 61. Last but not least, I have two diagonals in a parallelogram, and this one diagonal, we'll call it AC. It has one piece that's 5y, another piece that's 4y plus 4. The diagonal is bisected by the other diagonal, so we know that these two pieces are congruent. So we can set them equal. Solve for y, subtract 4y from both sides, and get y to be 4. So kind of similar to a lot of stuff we've done, take a property, apply it to a situation, set up an equation, and solve. So I want you to try this problem. It's important that you actually try it. Give it a shot. Even if you're wrong, make sure you try it. I want you to find x. I want you to find y. Kind of looks like we put two of the example problems together, so you're going to have to do two different equations.